Distillation towers are designed in a variety of ways to meet the demands of particular applications. A distillation tower, or column, can be categorized by the number of products that leave the tower. Two common types of towers that are identified this way are binary towers and multi-draw towers. A binary tower separates a feed into two products. For this reason, you may also hear a binary tower referred to as a two-product tower. Some binary towers separate one light component from a range of heavier components, but they are still considered to be binary towers because only two products leave the tower. Multi-draw towers separate a feed into more than two products. A product that leaves a multi-draw tower is referred to as a draw or a stream. Multi-draw towers are also referred to as side draw towers because some of the products or draws are taken from the side of the tower. For example, one type of multi-draw tower has three draws, one at the top, one at the bottom, and one near the middle. Because a draw or cut is taken out of the middle of this tower, this type of tower is sometimes referred to as a heart-cut tower. Multi-draw towers can also have more than three draws to separate several products from a feed. This one is an atmospheric tower in a crude oil distillation unit. An atmospheric tower is so named because distillation takes place in it at or near atmospheric pressure. Now that we've established the difference between binary towers and multi-draw towers, let's focus on the operation of a typical multi-draw or side-draw tower. The multi-draw tower illustrated here is used to separate a mixture into four products. Each product may be made up of one or more substances. The tower has four draw-off lines located at different levels. The draw-off lines provide a means for removing the products of the distillation. We'll number the products 1 through 4 to identify them. The illustration also shows two devices called strippers or side stream strippers, a condenser, a receiver, and a reboiler. Cooling water reaches the condenser through this line. Steam reaches the strippers through these two lines. And steam reaches the reboiler through this line. After the feed mixture is preheated and introduced into the tower, the heaviest components move down the tower, while the lighter components vaporize and move up the tower. The temperature at each draw-off point is important for the proper separation of the products. For example, the temperature is the highest at the bottom of the tower, where product 1 is drawn off. Here, the temperature is hot enough to vaporize the components that become products 2, 3, and 4, but it is controlled to minimize the amount of product 1 that vaporizes. If we move up the tower to the area where product 2 is drawn off, the temperature is lower than it is at the bottom of the tower. While there may be some overlap of products in this area, the concentration of product 2 is highest in the liquid that is drawn off at this point. If conditions in the tower are controlled properly, the concentration of each product is highest at its respective draw-off point. Let's take a moment to see how draw-off is collected. The liquid in each tray in the tower collects to the height of a weir, which is a dam-like barrier that holds the liquid on the tray at a specific level. If the tray is at a draw-off point, a portion of the liquid is drawn off through a draw-off line. The liquid overflow from each tray is allowed to flow to lower trays through passages called downcomers. This liquid is called internal reflux. This arrangement helps to ensure that any heavier components of the liquid have a chance to travel down to their proper draw-off points. The liquid that is drawn off by each side draw line goes to a side draw stripper. Each stripper is basically a small distillation tower. Its function is to remove or strip off any lighter products from the liquid. Liquid from the tower enters at the side of the stripper. In the stripper, the liquid is heated by steam, which causes any lighter products in the liquid to vaporize. The vapors that are produced are reintroduced into the tower above the tray from which the original liquid was drawn off. The liquid that is left over in the bottom of the stripper is drawn off as a product. The products or cuts obtained from the distillation process are sometimes called fractions. For this reason, distillation towers are sometimes called fractionating towers or fractionators. The physical dimensions of distillation towers may be different. In general, they are most affected by three main factors: the relative volatility of the feed components, the feed rate, and vapor loading. Relative volatility is the relationship between the boiling points of the feed components. Feed components that have a low relative volatility are difficult to separate because their boiling points are close to each other. In order to effectively separate the components of a feed with a low relative volatility, a tower requires a large number of trays, and in order to accommodate those trays, the tower must be fairly tall. The second factor that affects the physical dimensions of a tower is feed rate. Basically, higher feed rates require towers that are larger in diameter. The third factor that affects the dimensions of a tower is vapor loading. Vapor loading refers to the total volume of vapors generated by the reboiler and the vapors produced as a feed enters the tower's flash zone. The flash zone is the section of the tower where the feed enters and some of it vaporizes. Higher rates of vapor loading generally require a larger diameter tower. Lower rates of vapor loading can be handled in a tower with a smaller diameter. Some distillation towers operate at a low pressure. In these towers, a tremendous volume of vapors may be produced, so the diameter of the tower must be large to handle the vapor volume. Since a lower volume of vapors will be produced in a distillation tower that operates at a high pressure, the diameter of the tower can be relatively small.